Hello everyone, this is Pritika Patel working as an assistant professor in Computer Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today in this session, we are going to discuss about minimum cost spanning tree algorithm, which is the topic of subject data structure of second year third semester. Now coming to the point, minimum cost spanning tree. First of all, what is minimum cost spanning tree? With the application of weighted graph, if it is often necessary to find a spanning tree for which the total weight of the edges in the tree is as small as possible. Such a spanning tree is called a minimum spanning tree or minimum cost spanning tree, right? So simply minimum cost spanning tree is nothing but the spanning tree which have minimum cost of edges, sum of minimum cost of edges. So a minimum cost spanning tree is a spanning tree of least cost. Here there are two popular techniques for minimum cost spanning tree, that is Prim's algorithm and the Kruskal algorithm. Now first one is Prim's algorithm. Step number 1, remove all the loops. Here loops, that is nothing but any edges that starts and end at the same vertex in the vertex is loop. Step number 2, remove all parallel edges between two vertices except the one with least weight. Step number 3, choose any arbitrary vertex as a root. For all vertices, repeat step number 4. So step number 4 is check outgoing edges and select the one with less cost and with no cycle. So here example of Prim's algorithm. Find the minimum cost spanning tree from the following graph. Right? Here one graph is given which having vertex S, A, B, C, D and T, and all the graph having some weight. All the graph is connected with edges and this edges having given some vertex, right? Here some multiple edges are also there. Here A to B have two edges, right? One edges which having weight 6 and another edges which having weight 9, right? Here graph in this graph vertex C having self loop, right? This is the self loop because it is start from here and at also end at this vertex, right? So now step number 1 and step number 2, remove all loops and parallel edges, right? Because in algorithm steps we have seen that step number 1 is remove all loops. So in step number 1 we have to remove all loops. Here only one loops at vertex C, so we have to remove these loops in step number 1, right? And step number 2, that is remove all parallel edges, right? Remove all parallel edges. In this graph only one edge is having multiple edges, or we can say that parallel edges, right? But we have to choose the edge with least weight, right? So here least weight is 6, so we have to remove this edge which having weight 9, right? So here we choose the edge which have least weight 6, right? So in step number 1 we have to remove all loops, and step number 2 we have to remove parallel edges, right? Now step number 3, choose any arbitrary node as a root node. In this case, we have choose S as a root node, right? Step number 4, check adjacent or outgoing edges and select the one with less cost and with no cycle, right? So here S, we have to select S as a root node, right? So we have to find the adjacent of S, right? Adjacent of A, that is A, sorry, adjacent of S, that is A and C, right? Now we have to select one with less edge. Here this edge having weight 8 and this edge having weight 7, so we have to choose this edge which having weight 7, right? So this is selected, right, for minimum spanning tree, right? Now adjacent of A, adjacent of A, that is S, C, B, right? But A and S is already selected. So from B and C, here A to B is weight 6 and A to C having weight 3. So we have to choose this minimum weight 3. So this path is selected for minimum cost spanning tree, right? Now adjacent of C, that is adjacent of S, that is S, A, B and D, right? But A and S is already selected, right? So from B and D, the minimum weight of graph, that is 3, right? So we have to choose this edge for minimum spanning tree, right? Now adjacent of D is B, T and C, right? But C is already selected. So from B to T, cost of this edge is 2, right? Now the weight of D to T and D to B is 2, which both are minimum. So both edges are selected. Now we have completed all the vertex, right? So now calculate minimum cost. So minimum cost of this spanning tree is S to A, that is 7 plus 3 plus 3 plus 2 plus 2 equal to 17. So this is the minimum cost spanning tree, right? So this is the example of Prim's algorithm. Now next is Kruskal algorithm. Step number 1, remove all the loops. Any edges that start and end at the same vertex is loop. Step number 2, remove all parallel edges between two vertices except the one with least weight. Step number 3, arrange all edges in their increasing order of weight. For all vertices, repeat step number 4. Step number 4 is add the edges which has the least weight and with no cycle. Right? So this is the steps for Kruskal's algorithm. Now example of Kruskal algorithm. Find the minimum cost spanning tree from the following graph. Here one graph is given and from this graph we have to find the minimum cost spanning tree by using Kruskal algorithm. Now here what is the difference between Prim's and Kruskal algorithm? In Prim's algorithm we have to find the one node as an arbitrary vertex, right? One vertex as an arbitrary vertex, right? Now from this vertex we have to find the adjacents of this that vertex and we can choose the minimum edge from this adjacent vertex itself, right? Whereas in Kruskal's algorithm, we have to choose any edges, right? We can choose edges between any vertex given in this graph, right? So we can select any edge which is having minimum edge from anywhere. So this is the difference between Prim's and Kruskal algorithm, right? In step number 1 and step number 2, remove all loops and parallel edges, right? Here one graph is given. In this graph, loops is over here, that is vertex C. So we can remove these loops and parallel edges is here. So we have to remove the parallel edges with maximum cost and choose the edges which have least weight. Now step number 3, arrange all edges in their increasing order of weight, right? So now we have to arrange all the edges based on their weight. So B to D is having weight 2, then D to T is having weight 2, A to C having weight 3, C to D having weight 3, C to B having weight 4, B to T having weight 5, A to B having weight 6, S to A having weight 7, S to C having weight 8. So here in this table we are arrange all ages in increasing order of weight, right? Now step number 4. Add the ages which has the least weight and with no cycle, right? So here we will choose the age which having minimum age 2, right? Then minimum weight 3, right? And then we have to choose this vertex, right? Because here we have to cover all the vertex, right? So we have to choose the ages from this table, right? So here we can choose this B to D, right? So B and D vertex is covered and which is having minimum weight 2. Then D to T, so B, D and T is covered with minimum weight, right? Now A to C, so A and C is also covered with minimum weight 3. Then C comma D, right? C to D having weight 3. So now how many vertex is covered? B, D, T, A, C, right? This vertex is already covered. Now here C to B having weight 4, right? But C and B both are selected. Both vertex is uh, covered in previous ages, right? So we can't choose this C to B because it's having weight 4 and whatever the ages we have selected which have minimum weight, right? So here we can't choose this. Now next B to D having weight 5, but B and T vertex is already choose, right? Now A to B having weight 6, but A and B is also covered in previous ages, right? Now S to A, now S A and SC, these three C is already selected. So now S comma A is selected because which is having weight 7 and S to C. Here from these two edges we have to cover the vertex S, right? Which is having minimum edges. So here 7 is minimum. So we can choose these edges which have least weight with no cycle. We have to take care that there is no cycle is occur by choosing these edges with least weight, right? So we can choose these edges. So minimum cost is equal to 7 plus 3 plus 3 plus 2 plus 2 is equal to 7. So minimum cost of this uh, graph is equal to 17, right? So this is the example of Kruskal algorithm. So in this uh, session we are going to discuss about minimum cost spanning trees algorithm, that is Prim's and Kruskal algorithm. Thank you.